Question 4.1, using molecular formula, write the balanced equation to show the formation of compound A. Okay, so can you see that we are going from 2-butene and we are doing combustion. Combustion is the reaction of a material with oxygen to produce carbon dioxide and water. Then we said how to balance a combustion reaction. We said that there are 3 steps, and you should do it in these steps in order for it to work out very nicely. Step 1, balance the carbon. Step 2, balance the hydrogen. I'll show you how it works now. And then step 3, balance the oxygen. Okay, so, and you can do that for any combustion reaction. So they want us to do the combustion reaction with 2-butene. So we need to know what 2-butene looks like. 2-butene is an alkene molecule with 4 carbons. And on carbon number 2, there is a double bond like that. So that is what butene looks like. And then, of course, it's got all of these hydrogens around it. So what would the molecular formula of that molecule be? Well, that would be C4, and then there should be 8 hydrogens. C4H8, 1, 2, 3, 4, 5, 6, 7, 8, plus oxygen. That is how a combustion reaction works. And we said that the products are always going to be carbon dioxide and water. Okay, now we said that to balance this thing, you should always do the carbon first. So let's go do the carbon first. So there are 4 carbons on the left-hand side, and there is only 1 carbon on the right. So we should put a 4 over there. Then we should balance the hydrogen. So there are 8 of them on this side and only 2 of them on this side. So to balance that, we would put a 4 over there. And then lastly, we should balance the oxygen. So can you see that there is 8 oxygen molecules over here, because you say 4 times 2, and then there's another 4 oxygen atoms over here. So there's a total of 12 oxygen atoms on the right-hand side. And so on the left-hand side, we would need to put a 6 in the front in order to make sure that there are also 12 oxygen atoms. 12 oxygen atoms on the left. Okay, so that is how you would do that question over there. I'm now going to move on to the next question. Right. Question 4.2, write down the reaction conditions. So guys, can you remember a few months ago, we did organic chemistry reactions, and we said, remember, we looked at all those different reactions, like there was like 12 or 13 of them, addition, elimination, all sorts of reactions. Now, they want to know what are the reaction conditions for reaction P. So where's reaction P? Okay, reaction P is over here. Okay, so I'm going to go through this nice and slowly. What you should identify is that this molecule over here is an alkane molecule. That is alkane. So let's say here, alkane. And then this molecule over here is it's got a halogen, so it means that it is a halo alkane. Now, you might not remember this, maybe you do, but there was definitely a reaction that you and I looked at a while back where you go from an alkane to a halo alkane. We said it was a substitution reaction, and the reaction conditions that you need, this is the one that needs UV light. You remember that? There's a one that needs UV light. That is this one. Okay. So those are the reaction conditions for question 4.2.1. Now for question 4.2.2, it says reaction Z. So where is reaction Z? Okay, so reaction Z is this one over here, where we have, it's this one here, guys. So it's a haloalkane turning into a alkene. So yes, we definitely looked at something like this a few months ago, where we said that you can go from a haloalkane to an alkene. I'll give you an example. If you have a molecule like a butane molecule that has a bromo, you can definitely turn that into an alkene molecule. All that you have to do is you have to knock off one of the bromos, for example, and then you knock off one of the hydrogens, for example. And then what you form is a molecule that would look like this. It would have a double bond, or no, let's say a single bond for now. So you would have that over there. And so you can see that we have eliminated the bromo and the hydrogen. So we've taken away those two. And so because of that, we have to put a double bond in order to fix that up. So we can definitely go from a haloalkane to an alkene. Now, the reaction conditions for this one is this is the one where, remember there was that big thing that I kept talking about where I said that concentrated and dilute and concentrated and dilute. And I kept going on and on and on about that. This is the one where you have to use a concentrated base. Okay, if it doesn't feel 100% for you right now, that's pretty normal. You guys are on holiday, but maybe just go over the organic videos, the organic chemistry reaction videos, just to remind yourself again. But you need to use a concentrated base. And we also use high temperature for that reaction, high temperature. And so that's the reaction condition for reaction Z. Okay, hope that makes sense. Right, so let's just see what they want here. So in this question, they say, study the formation of compound B. Study the formation of compound B. Okay, compound B is over here. So how is compound B formed? It's formed from this reaction over here. Okay, can you see that? And it says write down the IUPAC name and the structural formula of compound B. So let's try to understand what is going on here. So we have a butene molecule, which is a type of alkene with a double bond on the second carbon. That's what they've told us. Right. And then, guys, remember that this is an alkene molecule. Can you remember that alkenes can do 4 different types of reactions? 1, 2, 3, and 4. We said that they could undergo hydration, which was when you add H2O to them. They can undergo hydrogenation, which is when you add hydrogen. They can undergo halogenation, which is when you add any type of halogen, and then they can also undergo hydrohalogenation, which was when you add a hydrogen and any type of halogen. Okay, so that is what the alkenes are able to do. Those are all addition reactions. So what we can see here is that they are adding water. They're adding water, and so that would be this reaction over here. So there is a hydration reaction that is busy taking place. So what that actually means is that we are going to be adding water to this molecule. So we're going to say plus water, but I like to write the water as HOH like that. And so what happens is that one of the hydrogens, or this hydrogen, is going to go maybe attach over there, and then the OH is just going to go and attach on the other side. And so your final product would look something like this. And then I'm going to show you in a different color. I think I'll use this color, H and OH. Like that. Okay, so that is what we formed at compound B. So they said write down the IUPAC name and the structural formula of compound B. So this is the structural formula. That is the structural formula. And the name of that would be butan. And then on carbon number 2, there is an alcohol. So we say butan 2-ol. Right. Question 4.3.2 says name the homologous series. Now, Kevin, what the hell is a homologous series? Guys, a homologous series is like alcohol, haloalkane, alkene, alkyne, aldehyde, ketone. All of those are homologous series. So it's like the type of molecule. So this is definitely an alcohol. So we can just say here, alcohol. All right. And then is compound B a primary, secondary, or tertiary product? Give a reason for your answer. So if you have something like this, or even something like this. So what you do is you look at the OH over here. So you look at this OH, and then you look at the carbon that is attached to the OH, which is this one over here. And then you look and see how many carbons are touching that one. So can you see that there is only one carbon touching that one? So that's 1. If we look at this example, you look at the OH first. Then you look at the carbon that is touching that one, which is this one. And then you see how many carbons are touching this one, but that is 0. If the answer is 0 or 1, then we call that primary alcohol. Okay. Let's quickly look at another example. If we have something like this, so what you do is you look at the number of you look at the OH, then you look at the number of carbons that are, or you look at the carbon that is touching that one, which is this one over here, and then you see how many carbons are touching that carbon. So that's going to be 1 and 2. So whenever you get something like that, then it's called secondary. And then if it's tertiary, let's switch my video off here. If it's tertiary, then it looks something like this. So you look at the OH first, then you look at the carbon that is touching the OH, and then you see how many carbons are touching that one. So that would be 1, 2, and 3. Okay, so that's a quick summary of primary, secondary, and tertiary. So their question is this molecule primary, secondary, or tertiary? So what you do first is you look at the OH, then you look at the carbon touching that one, and then you see how many carbons are connected to that one. So that would be 1 and 2. So that means that this must be a secondary alcohol. Okay, then 4.3.4, name the type of reaction that results in compound B. So you could say addition, whoops, that's not visible. You could say addition, but you could also say hydration. Okay, remember we said that when you go from an alkene and you become an alcohol, then you are doing addition because you are adding molecules onto the alkene. All right, guys, so let's move on to the next one. Write down the structural formula of compound C. Okay, so let's see what's happening now. So we have compound, let me just move that out the way. Okay, so we have compound B, which we already looked at now, and we said that it's an alcohol that looked something like this. Okay, with a whole lot of hydrogen, of course. And then what we're going to do is we're going to take that and we're going to add HCl to it. So what happens is that this Cl is going to replace the OH. That's going to replace the OH. And so what happens is that you end up with something that looks like this now. Like that, and then the rest of the molecule is exactly the same. You've just got all these hydrogens everywhere. Okay, so they said write down the structural formula of compound C. This is the structural formula of compound C. Of course, you would have to add a whole lot of hydrogens and things like that, but that is the structural formula. Okay, then it says write down the IUPAC name of the organic compound D. Okay, an organic compound is anything that has carbon in it, has carbon. So for example, water is not a organic compound. Right, let's try to see what's happening here. Haha. So let me explain something to you guys. Can you see that this molecule over here is an alcohol? Then what they're doing is they're using heat. Did you know that this symbol over here stands for heat? So they're heating it up. Now, whenever we heat something up, that usually means elimination. When you heat something up, you are going to be doing elimination. Okay, so let me show you exactly what's happening in this reaction. Let's get rid of this one. All right, so let's get a different color. Okay, so I'm going to draw this molecule out quickly, which is a alcohol. So it's got C123, C12, 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 and then an OH. That is what this molecule looks like over here. Now they are going to be doing elimination. So what that means is that they're going to knock off this one, and then you're going to go to the carbon next door, which is this one here, and you're going to eliminate one of the hydrogens. Okay, so your resulting product is now going to look something like this. You're going to have all the 4 carbons, of course, and then you're still going to have these hydrogens over here and these hydrogens over here. You've still got that one, that one, that one. So can you see what's happened? We have eliminated something over here, and we've eliminated the OH over here. So because of that, now we have a little bit of a problem with these carbons over here, because those carbons, they only have 3 bonds now. Can you see that? So the way that we fix that is we put a double bond over there. So now that has a double bond. And then the other molecule as the product, that's why they've got compound B and compound E over here, would be the H that came off and the OH that came off over here, and together they would make water. So they said, write down the IUPAC name of the organic product. The organic product is this one over here. So if I draw that a little bit bigger for us, that's what it looks like. So if we want to give that one a name, it's definitely a bute because it's got 4 carbons. And then it's going to be on carbon number 1, there is an ene. So we'll say that there's a double bond. And so it's going to look like that. So that'll be the name of that molecule over there. Write down the structural formula for the inorganic product E. Write down the structural formula for the inorganic product E. That's so weird. I've never seen that before. We know that the inorganic product here was just a water. So the structural formula of water, I've never seen them ask that before, but the structural formula of water would be something like that. Okay, so that's interesting. Then they say, write down the IUPAC name and draw the structural formula of compound F. Now, I wonder if you guys can remember, if you look over here, we've got an alcohol. And then we are reacting it with this molecule over here. Now, if I write that molecule the correct way round, we should identify this as a carboxylic acid. And we should remember that if you take an alcohol and you react it with a carboxylic, I'm just going to say carboxy, then you're going to form an ester. Remember that? I'll give you a quick example so you can try to remember. If you take an alcohol, let's say we take an alcohol over here, and then you react that with a carboxylic acid, what happens is that this this OH gets eliminated and this H gets eliminated, and then you form a product that looks something like this. So then you get the CCO, and then you're going to have 3 carbons over here like that. So can you see that these two molecules, they just link up together? And the water molecule gets released as a inorganic product. So that was esterification. Okay, so let's answer their question now. So they say, write down the IUPAC name and draw the structural formula of compound F. Okay, so they want to know what the product is going to look like. So to do that, we are going to have to, let me get rid of all of this. So to do that, we are going to have to draw the alcohol. So let's draw the alcohol. How many carbons? 1, 2, 3, 4. One, two, three, 4. Okay, good. And then we're going to react that with the carboxylic acid. Now the carboxylic acid has 1, 2, 3 carbons. But what I like to do is I always like to put the carboxylic acid on the side of the alcohol. Just makes it easier to work with. Okay, and so what happens, as we said, is that the alcohol is going to lose its H, and the carboxylic is going to lose the OH like that. And so we are going to form a product that is going to look something like this. So I'm putting all the alcohol first, which is these 4 carbons. And then we're going to have the oxygen, which is this oxygen over here. And then the rest of the molecule like that. There we go. And then, of course, we should put all the hydrogen. Then they said, write down the IUPAC name and draw the structural formula. Okay, so this is the structural formula. Now, the name of the molecule, can you remember how to name an ester? You always say the alcohol first. So alcohol first. And then the carboxylic acid. So the alcohol has 1, 2, 3, 4 carbons. So what we do is we say butyl. And then the carboxylic acid part has 3 carbons. And so that's going to be propanoate. And so that is the name of that ester, butyl propanoate. Okay, and then the last question, 4.9, name the type of reaction that results in compound F. There are 2 types of names that you are allowed to use. You can say esterification, but you can also say condensation reaction. It's also a condensation reaction. Okay, so any one of those 2 is good enough.